That brings us to our third variable, right? Temperature. We know that the rest of the world uses everything in degrees Celsius, but for us, whenever we make calculations, it always has to be in Kelvin. This is the number one mistake that students make. They don't convert their temperatures to Kelvin, they just leave it in Celsius. And the problem is that when you go to do these problems, that sometimes you're dividing. Well, when you divide by a number that's in degrees Celsius, it's going to be small, but when you divide or multiply by your temperature in Kelvin, it's going to be much larger. The other is Celsius has negative values, right? There is no negative Kelvin. 0 Kelvin is as cold as it gets, it's absolute zero. So you always have to have temperature in Kelvin no matter what in your equations. Now I know that last unit we used Q equals MC delta T, and because it was delta T, it didn't really matter whether we were in Kelvin or Celsius, right? Because if this is our equation here, if let's say you had something at 100 degrees Celsius, well, that would be 373 Kelvin. And if you had something at 0 degrees Celsius, then it would be 273 Kelvin. Well, because we were solving for the change in temperature, well, the difference between Celsius, right, the difference between our final and initial there is 100. Well, in Kelvin, the change in temperature is still 100, so it didn't matter. But now we're going to be multiplying and dividing other variables, our moles or our volume or pressure, our fourth variable, by the temperatures. And so now, because we're not finding this change in temperature, it has to always be in Kelvin, not in Celsius. Let's see here. So just real quick, right, make sure that you know that equation. So what's 25 degrees Celsius in Kelvin, or what's 258 Kelvin in degrees Celsius? Remember, you always want to show your work to prove your work, prove you know what you're doing. So 25 plus 273 gives us our Kelvin, or the opposite, right? 258 minus 273 equals negative 15 degrees Celsius. We're just using this equation here the whole entire time. You don't have to write the equation down, but you do need to show your work. And you'll have one or two of those, I believe, on your homework assignment. That brings us to our last variable, pressure. Right, we talked about that already. It's the result of the particles hitting the walls on the container. Every time a particle hits a wall, it applies pressure. If there's more particles and they hit the wall more often, it causes more pressure, right? So when we pump up a tire, we put in more moles of the air, right? We put in more particles, so therefore they hit the side of the container more often, causing more pressure. Or if you made like the volume of a container really small, then the gas particles wouldn't have to travel very far and they would hit the side of a container more often, and that would cause more pressure, right? So if you have your container and you have your particle, if it's moving really fast, it's going to hit the wall, hit the wall, hit the wall more often, causing more pressure, right? Or if you have more gas particles in there, then because there's more particles, the walls will get hit more often, causing more pressure. Or if it's a small container, it doesn't have to travel very far, right? It only has to travel to here, where before it had to travel all the way across. Now it just travels these short distances, so again, it hits the side of the container more often, causing more pressure. The symbol here is a capital P, not a lowercase p, but a capital P. Now, there are a ton of different units of measurement for pressure. And there are going to be certain ones that you have to be in for certain problems, but you're going to have to know these relationships between them. This is something that you're going to have to memorize all these numbers for the test. Okay? And part of your homework is going to be to convert from one to the other, because that's going to happen a lot in your homework. this here is our last slide for this video, and then we'll stop. Atmospheric pressure, right? The pressure exerted by the weight of the air in the atmosphere. So basically, if this is the Earth and you figure there is air all over the place, right? There's air particles everywhere and they're moving around. Basically, if you wanted to figure out the air pressure right here, if you could find the weight of all those particles that are filling this column all the way out into outer space, if you could figure out the weight of all those air particles, that's basically what's causing the pressure. Okay, pressure is force over area. So basically, if the force is more or less the weight of these particles, so if I could find the weight of all those particles in that section over the area that it's applying it, I would know what kind of atmospheric pressure it's exerting. And the reason why I wanted to go, to that last slide, oh, I went too far back. There we go, is we need all of these values in here to, I wish I could go back and erase, but I can't. So we need all those values in there to use for the conversions, right? So that means that 1 ATM equals 101,325 pascals, or 1 ATM equals 760 millimeters of mercury, or 1 ATM equals 760 torr, or 1 ATM equals 14.7 pounds per inch squared. Well, it's not always 1 ATM equals, they all equal each other, which means that 101.325 kilopascals also equals 760 torr, and 101.325 kilopascals also equals 760 millimeters of mercury. So you can use all of those to make your unit conversions between the different ones. So like an example would be, let's say I said you had, gosh, I wonder if I can clear this out somehow. Doesn't look like I can. Anyways, let's say you had 2.3 ATMs, and I wanted to know how much that is in pounds per inch squared. Well, you would do dimensional analysis. I need ATMs to cancel, and I need to go to pounds per inch squared, so I would use this relationship of 1 ATM, right? 1 goes with ATM, and it equals 14.70 pounds per inch squared. So I would do 2.3 times 14.7, right? And my units of ATM would cancel, and I would get my value in pounds per inch squared. Another example might be, let's say you have 345 pascals, and you want to convert it to millimeters of mercury, right? Well, I need the units of pascals to cancel, right? And I said I'm going to go to millimeters of mercury. So in pascals, that's here, right? 101,325. So I've got to put that down here, 101,325. And we want to get to millimeters of mercury. So that's our 760. So that means on top of the fraction, I've got to put 760. My units of Pascal will cancel. And now, if I do 345 times 760 divided by 101,325, then we will get our answer in, millimeters of mercury. And those are the very last parts of your homework assignment. So what I'd really like you to do is take a break from watching the video, go and do the first 2 pages of your homework, and then on the very last page of your homework, do all the unit conversions between pressure.